Today we are starting study design. And so please note these are the things that you're going to be doing for the week. This is self-paced, so you can do what you need to do from last week, but these things need to be due by Friday. Please remember next week we're out for a week, so make sure you're done by Friday. Because next week also starts the beginning of the second half to first semester. So you're going to complete these notes and the videos for a grade on experiments. And then you can practice on Khan Academy. The two that are linked are types of statistical studies and experiment designs. And then last, we're going to end the week with a project. Which hand rules? It'll be a partner project. So note, you will be turning in your notes that you watch the videos. There's a lot of practice problems on these notes as well. Last week we did a great job with doing our little mini project on response bias. So for experiments, these are the several things that we're going to be talking about. Mostly are highlighting observational versus experimental studies. What are experimental units, explanatory and response variables, and what are the treatments we're going to use in an experiment. We're going to talk about the purpose of comparison, random sample control, and replication in an experiment. We'll talk about the placebo effect and the purpose of blinding in an experiment. And then interpret the meaning of what statistically significant actually means in the context of an experiment. So the first thing on our list is observational studies versus experiments. And so in an observational study, you're basically just observing individuals and measuring only the variables that you're interested in. But it does not attempt to influence the responses, which is what an experiment does. An experiment, you're deliberately imposing some treatment on some individuals to measure what their responses are. And so in order to understand this, we have to review what a response variable is. And so a response variable is basically the outcome of the experiment. And then your explanatory variable is exactly what it says. It kind of explains or influences changes in a response variable, and we'll talk more about that. So if your goal is to understand cause and effect, experiments are the only source of fully convincing data. The distinction between an observational study and an experiment is one of really a lot of importance in statistics. This is when you can start getting into spin, you can start talking about other influences, etc. So if you want cause and effect, experiment's going to be your option. Okay, an observation versus experiment. Observational studies are often failures simply because of confounding between the explanatory variable and one or more other variables. And so that's why we need to know how to design a well-designed experiment, just like you need a well-designed survey so you don't have response bias. It's the same with observational studies. Confounding is basically when you can't when there is an outcome, but you can't say for certain what variable had the most impact on that outcome. So you can't really distinguish the effects between several variables. So let's check our understanding of what the main differences are between an observational study and an experimental one. So here we've got this laptop, and we want to know if reducing screen brightness will increase our battery life. And so we're going to look at 30 new laptops of the same brand. Again, that's to make control in this experiment. And they're going to choose 15 at random. And you know how to do a random sample. You would take your 30 computers and number of them from 1 to 30, and then do a random sample either on your computer, or you would use that table and choose 15 of them to have their screens adjusted to the brightest setting. And then the other 15 you would just leave at default settings. And then they measured how long each machine's battery lasted. In this case it says batter lasted, but there's a misspelling here. There should be a Y. And so then is this observational or experimental? And so the answer is this is experimental. And the reason this is experimental is because you are actually doing a treatment. You have changed the settings of 15 of your computers. thereby making it an experiment. You can actually justify your results. You can say that there was or was not a change in the battery life based on the 30 laptops that you experimented on. Okay, so here we're talking, this was actually an article in ABC News. It was teenagers who eat with their families at least 5 times per week are more likely to get better grades in school. And it was based on a sample survey conducted at Columbia University. So is this an observational study or an experiment? And so the answer here is this is observational. And the reason is you have no control. You didn't say that so many teenagers are going to eat with their families exactly 5 times per week, and so many teenagers are not going to eat with their families so many times per week. That would cause it to be an experiment. But because you're just observing teenagers who eat with their family at least 5 times per week and those that don't, this would be observational. So the explanatory and response variables. So the response variable that you're looking at this is better grades in school. So you would probably say their GPA. And then the explanatory is how many times they ate with their family per week. How many meals, how many family meals they had would be your explanatory variable. And so explain clearly why such a study cannot establish cause and effect relationship. So if you wanted to suggest a variable that could be confounded with whether families eat dinner together, well, some people might argue that families that eat together might have a parent or parents who are more invested in their students' education. And so therefore the GPA, the increase in GPA is not because they eat as a family, but it's more because their parents are more invested in their schooling. So they do more to help them out at school. Okay, so the language of experiments. So an experiment is a statistical study in which we actually do something, and we call that something a treatment. And we do this to people, animals, or objects. And that's what we call the experimental units, to observe their response. And so here's some basic vocabulary. You're going to need to refer back to this chart frequently while watching the video because these words are new to you, and we are going to use them when we're looking at other studies and analyzing other studies. So a specific condition applied to individuals in an experiment, that's what we call a treatment. Some experiments have several explanatory variables, and a treatment is a combination of specific values to these variables. They're also called factors. They're the explanatory variables in the experiment. And then the experimental unit are the individuals. And like we said, they can be people, animals, or objects. But of course, we got to make things a little bit more complicated. So when the units are humans, then they're also called subjects. So when are you going to use this stuff? So researchers at UNC were concerned about increasing dropout rates of their state's high school students, especially for low-income students. And so they took surveys of people that recently dropped out. And what these surveys revealed was that students started to lose interest during middle school. They said they couldn't see a connection between what they were studying in school and what they wanted to do in the future. And so to change this perception, they developed a program called Career Start in North Carolina. And the big idea of this program is that teachers show students how the topics they're learning get used in specific careers. So they wanted to test to see whether Career Start was actually working. And so the researchers recruited 14 middle schools in Forsyth County, which is a county in North Carolina, to participate in the experiment. So they took 7 of the school students, chosen at random. They used Career Start along with the district's standard curriculum. So the other 7 schools just followed the standard curriculum. And they followed both groups of students for several years, collecting data on attendance, behavior, standardized test scores, level of engagement in school, and whether the students actually graduated from high school. And what they found was that students that were at the schools that used Career Start generally had better attendance and fewer discipline problems. They earned higher test scores, and they reported greater engagement in their classes. And they were more likely to graduate. So let's go ahead and identify the experimental units. In this case, we would call them subjects. the explanatory variable and the response variables, and the treatments that existed. Pause the video and you're going to write your answers in the space provided. So what you should have noticed is that, first of all, the experimental units are the students that attended the 14 middle schools in Forsyth County. Then we want to know, and we would call them subjects because they're students, they're people. The explanatory variable is whether or not Career Start has an impact. So the explanatory would be Career Start. And the response variables, in this case, there are several response variables. So you wanted to know the impact Career Start had on attendance. That would be a response variable. Behavior, standardized test scores, level of engagement, and graduation rate from high school. Those are all response variables. And then the treatments was, were you part of the group that had Career Start, or were you the part that only had Career Start in addition to state standards, or were you just one of the schools that just had the state standards? All right, so that's what we're going to be doing. Here's our next example is growing tomatoes. So we want to know, our statistical question is, does adding fertilizer affect the productivity of tomato plants? And how about the amount of water given to the plants? So to answer these questions, a gardener plants 24 similar tomato plants in identical pots in his greenhouse. He will add fertilizer to the soil in half of the pots. Also, he will add water to 8 of the plants with half a gallon of water per day, 8 of the plants with 1 gallon of water per day, and the remaining 8 plants with 1.5 gallons of water per day. At the end of 3 months, he will record the total weight of tomatoes produced on each plant. So you're going to write what you think the experimental units or subjects, the explanatory and response variables, and the treatments. And when you turn it in, I will give you feedback on it. You might need to pause and reread the video if you need to. The next example we're going to look at is, does caffeine affect pulse rate? So again, many students regularly consume caffeine to help them stay alert. So it seems plausible that taking caffeine might increase an individual's pulse rate. Is this true? So we did a study. One way to investigate this claim is to ask volunteers to measure their pulse rates, drink some cola with caffeine, measure their pulse rates again after 10 minutes, and calculate the increase in pulse rate. So I want you to, once again, identify the experimental units or subjects. What are the explanatory and the response variables, and what are the treatments? And again, you're just going to write your answers down on your note sheet, and I will give you some feedback when you turn that in. Okay, moving along.